All right. Well, thank you so much for the invitation. I'm happy to present my research to you. So the title of the paper is Credible Forward Guidance. And so the question we ask in this paper is this: what is the optimal time-consistent forward guidance policy? And the context in which we ask this question is this. So there's one well-known form of forward guidance policy at the ELB that is, that has attracted a lot of attention, and that's called lower for longer or overheating commitment policy. And in this policy, the central bank promises to keep the policy rate at the ELB for an extended period so as to generate a temporary overheating of economy. And many research has shown that this policy is very effective. But at the same time, this policy is known to have a time inconsistency problem in which the central bank has an incentive to renege on this promise of overheating ex post. And before 2020, most central banks did not adopt this overheating commitment policy. And one key reason was the time inconsistency problem, as pointed out by many policymakers before 2020. But since then, the Fed and ECB have moved in this direction, have become more willing to allow inflation overshooting after prolonged periods of ZLB. Okay, and so this is one quote from before 2020 that captures this concern about time inconsistency, and this is from Benoit Cœuré, the former board member at the ECB, who said the main challenge of such commitment type guidance is its inherent inconsistency over time, thus lack of credibility. When the time comes, the central bank may be tempted to deviate from its prior commitment. Once the benefits of higher inflation expectations in terms of front-loaded spending have been reaped, the central bank may not be willing to pay the bill in terms of higher inflation afterwards. And this is a possible explanation why, in practice, central banks have refrained from using forward guidance in a way that implies a measure changing strategy. And one way to overcome this criticism towards the commitment policy is introduce reputation into the model. And that's what I analyzed in my previous paper, in which I show that the optimal commitment policy can be made time consistent if reneging on the promise leads to loss of reputation and makes lower for longer policy ineffective in future crises, and crises occur with sufficient frequency and loss of reputation lasts for a sufficiently long period. And the paper I'm presenting today is a follow-up of this paper, in which I ask what would be the best allocation that central bank can credibly achieve at the ELB. So the idea is that even if optimal commitment policy is not credible, you may be able to do something more than discretionary policy. And what we do specifically is to analyze the optimal sustainable policy problem in a sticky price model with ELB. And in this problem, which I will formulate shortly, the central bank's optimization problem is subject to a sustainability constraint. And I'm going to assume that if the deviation from optimal sustainable policy occurs, the economy falls into a discretionary regime for a finite period. Okay. And what we find is that even when the optimal commitment policy is not credible, the central bank can still do better than the discretion and do some form of lower for longer policies. And in particular, or even though you have a shorter ELB duration and smaller overheating of the economy under the optimal sustainable policy than under the commitment policy, the welfare cost of ELB can be substantially made smaller under the optimal sustainable policy than under the optimal discretionary policy. And I'm going to also show, if I have time, is that the optimal sustainable policy is less history dependent and in a way less complex than optimal commitment policy. And thus, you could argue that it's easier for the central bank to communicate this type of policy to the public. And the key idea of time inconsistency can be captured by this figure. So what I show in the red line is the outcome of optimal discretionary policy, and what I show in the black line is the optimal commitment outcome. And I have two-state Markov shock behind this figure, and that lasts for 8 quarters. And you see that under the commitment policy, the central bank engineered this overheating of the economy. And through expectations, that's going to mitigate the declines in output when the shock is there. Okay, so that's the benefit of the commitment policy. But this policy is time inconsistent because once the shock disappears at time 9, you can be, or you are better off by raising the policy rate and closing this output gap. Okay, because zero output gap is optimal from that, period by period. So this gray area shows the temptation to renege. Okay, and the idea of reputation is that well, if the crisis can hit the economy in the future again, and if you cannot use commitment type policy in a future crisis, then you're gonna end up with this red line instead of black line. So that's gonna introduce the cost of reneging on the promise. Okay.
Daisuke.
Yes.
Can I ask a question?
Sure.
So, but this is, I can see the intuition, but then your big assumption is that those time-consistent policies in the long run, they leave expectations anchored, that even even if you renegate it, then you are still able to bring the expectations down where you want to. Those that don't remain the anchored during to the renegation. Is it the assumption that you have? Because, and I make this point because in your previous slide, when you have the benefit of reneging, then you have that, even if you renege, the expectations are such that you are able to re-anchor the economy to a zero output gap and drive the expectations in the way you want. Is it an assumption in your model, or you don't need to have it to make this point? Because I think the real danger of reneging is that if you do it, then you can de-anchor the expectations, and then permanently you will lose that anchor. And so maybe you wouldn't be able to bring the economy back at the good equilibrium that you would like.
So the assumption is that if the central bank reneges on the promise, then you're gonna be in this discretion world in which economy tanks a lot when the shock hits, and the economy is near the steady state when the shock is not there. So that's the assumption. And yeah, that's, I don't know.
Okay, let's go ahead when you show the model. I'll more specific. Thank you.
All right. Related literature, I'm gonna skip because I don't have much time. So this is a very standard new Keynesian model that's log linearized. And I'm gonna focus on a static Phillips curve model, but I have a result in a forward-looking Phillips curve model. And so the first equation is the consumption Euler equation, and the second equation is the static Phillips curve, okay? So Y is output, I is short-term nominal interest rate, pi is inflation, ST is a natural rate shock, okay? And so I'm gonna call this state contingent sequence of output, inflation, and the policy rate an outcome, okay? And an outcome that satisfies these constraints called competitive outcome. And there's a two-state Markov shock. So ST takes two values, R star, that's positive, RC, that's negative. And PH denotes crisis frequency, and PL denotes crisis persistence. And the value function for the central bank is given by expected discounted sum of future utility flow, and each period utility is given by a standard quadratic objective function. And so there are three important concepts. One is discretionary outcome, the second one is commitment outcome, and the last one is the sustainable outcome. And the discretionary outcome is defined in a standard way. So the program, so at each period T, the discretionary central bank solves the following problem subject to future policy functions and value function as given, and also subject to the private sector equilibrium condition. And let these things be the time invariant value and policy function that solves its problem. And you can use these objects to define the discretionary outcome. And the commitment outcome is, it's a time zero optimization problem once and for all. So the central bank chooses a state contingent sequence in order to maximize time one value subject to the private sector equilibrium conditions at time t. And the Ramsey outcome is the solution to this. And the key object of this paper is this sustainable outcome. So here the problem is very similar to the commitment outcome, but at each point in time and after any history of shocks, you are subject to this sustainability constraint, okay? That says that the continuation value of the problem has to be larger than or equal to a discretionary value function that is associated with discretionary program, okay? And the sustainable outcome is the solution to this problem, okay? And when I think about a problem in which deviation of the central bank will be punished only for finite period, I have a modified sustainability constraint in which the lower bound is given by a value that is associated with this, being in a discretionary regime for n period. And so once we compute this sustainable outcome, we can construct a plan that induces it and that is sustainable. And I guess this is a little bit too technical for a 30 minutes presentation. So, but the key thing is that, there's a definition of sustainability, which is that neither the central bank or private sector agents have incentive to deviate from the instruction given by the plan. If that is satisfied, I'm going to say that plan is sustainable. And so,
sorry, just jumping in. Is that a unique plan?
Also, sustainable. So, plan that are sustainable in this model is not unique.
Right.
So there will be a multiplicity. And actually, so there's infinitely many plans that we probably cannot characterize. Well, there's a computational way to characterize this, but I don't know. It's a very technical thing. But what I'm doing is I'm looking at the sequence of plans that has a specific structure and that are sustainable. And the specific structure is given by the problem I just showed you earlier. That gives you some specific structure in the sustainable plan I look for. All right. And so once I solve the sustainable outcome, so what I can do is I can construct a specific plan, which I call the Revert discretion plan, in which the economy follows the sustainable outcome as long as the central bank chooses a policy rate consistent with the sustainable outcome. And if the central bank has ever deviated from the policy rate consistent with the sustainable outcome, the economy falls into a discretionary regime, okay? And by construction, this plan is sustainable. And yeah, all right. Okay, anyway, so I'm going to solve the model using numerical methods. And these are the parameter values I use. And the punishment duration, I'm going to use 20 quarters, 60 quarters, infinity, and so on. It's a toy model. So the calibration I do is, okay, whatever. So let's see. So what I show here is the outcome from optimal commitment policy and optimal discretionary policy, black and red. And so this is a case in which the crisis shock lasts for 8 quarters and returns to a steady state level and stays there forever. And under the discretionary policy, the central bank keeps the policy rate at the ELB as long as the crisis shock lasts, okay? And raise the policy rate after the shock disappears. And output and inflation looks like this. And under the optimal commitment policy, what the central bank does, this is very well known, is that the central bank keeps the policy rate at the ELB even after the shock disappears. Okay, so it's like a 5-6 additional duration. And what this does is to create overheating of the economy. Okay, after the crisis shock disappears, and through expectations, that's going to mitigate the declines in output and inflation while the crisis shock is there. Okay, and yeah, so this is a commitment policy. There's nothing new here. Okay, and the reason this policy has potential time inconsistency problem is that once the shock disappears, the central bank has incentive. Well, the central bank can raise the policy rate and close the output gap. Okay, and because central bank has a quadratic objective function, zero output gap is better than positive output gap. So this is the incentive to renege. Okay. Now let me show you the sustainable outcome. So what I show in the black line, dash dotted black line and dotted line is the optimal sustainable policy with different punishment duration: infinity, 60 quarters, and 20 quarters. And in the case of infinity, actually the outcome coincides with the optimal commitment policy. But as the punishment duration gets smaller, the outcome, sustainable outcome, gets closer and closer to the discretionary outcome. Okay. And what's happening is that, so here we have this cost of reneging that's taken into account. Okay, so if you renege on the promise of overheating, by construction, I'm setting things up so that, well, if you do that, you're gonna be following this red line afterwards. Okay. And if you are in a discretionary regime, and if crisis shock hits the economy again, you're going to end up with this outcome in which output gap and inflation drops a lot. Whereas if you keep the promise of overheating now, then in a future crisis, you can end up with this black line, which is good. So these are the trade-off.
Right, can I ask a question?
Yeah.
So this mainly depends on there being another crisis relatively soon, where also the effective lower bound would be binding, right? And
yeah,
so like what if this would happen once every 20 years, then your story does not hold, or like what's the calibration that we need here?
Yeah, so that's a great point. So in my earlier paper, so I focused on the frequency parameter. So the idea is that if the crisis, so if you are in a Everson and Woodford world, in which the steady state is the observing steady state, so they have a two-state Markov shock with observing steady state. Once the crisis shock disappears, the crisis never hits the economy again. So in that environment, this policy, so there's no repetition possible. So, but as you increase the crisis frequency, you can rely more and more on this reputational mechanism. So if you hold all other parameters constant, you can always find a threshold value of crisis frequency above which this works and below which, or above which this reputation mechanism can make the optimal commitment policy credible, and below which you cannot do that. Yeah, but here, in this paper, what I want to emphasize is that even if crisis frequency is such that it's not high enough, large enough to make the optimal commitment policy credible, even in that case, you can still do better than discretion. You can just promise a little bit of overheating, not as much as optimal commitment policy. Then your incentive to renege is smaller, and thus, so what's happening here is that you are promising smaller overheating. So you have a smaller incentive to renege. This much, temptation can be overcome by this possibility that the future crisis can happen. Yeah, thanks. All right. So here what's happening, I'm showing you the impulse response function of the value when n is equal to infinity, 60, and 20. And what's happening is that when punishment duration is high, well, it's infinity, then so when this black line and the dotted red line touches, that's when sustainability constraint binds. So here, when the punishment duration is long, sustainability constraint is not binding. Here it's binding, and here it's binding. And because it's binding, you can promise smaller magnitude of overheating. But you can still, this is still better than discretion. Okay, all right. So just to kind of summarize, so there's a benefit and cost of reneging on the promise of lower for longer. And the benefit is to be able to eliminate the temporary overheating of the economy now. But the cost is you cannot use lower for longer policies in future crises. And for the promise to be credible, the cost has to be larger than or equal to the benefit. And when the punishment lasts for a shorter period of time, the cost is smaller. So for the promise to be credible, the promise to overheating has to be smaller. Okay. So
sorry,
do
you have a sense of the comparative statics, if you will, how the incentive to renege versus the punishment are changing when you vary the parameters, let's say the punishment or the frequencies? Do you have a figure like that?
In my previous paper, yes. Yeah, not in this paper. But the key parameter is this crisis frequency, and all other parameters affects both benefit and costs in sometimes in the same direction. So for example, how a change in kappa, what does that mean? So it's going to affect both benefit and cost in tricky way. So I cannot even remember how it goes, but so it's going to be like a quantitative thing.
That's
yeah. All right. So if you compute the warfare cost of the ELB, so you can see that so the top line is the warfare cost of ELB under the commitment policy, and the bottom line is the warfare cost under the optimal discretion. And you can see that even with very short period of punishment, like 5 years, you can do much better than optimal discretion. Okay. Oops. And so everything depends on this punishment duration. And so one way to think about this punishment duration is to think about like a reputation is specific to individual who is in charge of the central bank. So the idea is Alan Greenspan's reputation is different from Ben Bernanke's reputation and Jay Powell's reputation. So then, like the tenure duration of chairpersons at the central bank, if you look at these numbers, that might be a good way to think about what's the reasonable, value of this N. There's a more technically rigorous way to think about this question of what is the reasonable value of N, and which is a renegotiation proofness concept. And the idea is that when the crisis shock disappears and the central bank has incentive to renege, and let's say if the central bank renege on the promise, so there's there's a literature in game theory that thinks about what if you can renegotiate again after you renege on the promise. How that is going to affect how that's going to shrink the sustainable sets. Yeah, and there are different concepts of renegotiation proofness. And according to one concept of renegotiation proofness, the reasonable value we find is like 36 like quarters. Yeah. And under this value of n, what you see is, or what you're gonna end up is something like in the middle of commitment and discretion. Okay, so let me talk about history dependence. Okay, so here I'm showing you the outcome of commitment policy and the discretionary policy under different realization of shocks. Okay, and what I have on the left column is when crisis shock lasts for 1 quarter. What I have in the middle is when crisis shock lasts for 4 quarters. And what I have on the right column is what I show already, 8 quarters, okay? And what you can see is that the additional ELB duration depends on the shock duration. So if the shock duration is only for 1 quarter, the additional ELB duration under the commitment policy is like 2-3 quarters. But if the shock lasts for 8 quarters, the additional ELB duration is like 6-7 quarters. And the size of overheating of the economy depends on the shock duration. If the shock duration is shorter, the size of the promised overheating is smaller, okay? So that's what I mean by history dependence. So this is another way to see the history dependence of the commitment policy. So what I have on the horizontal axis is a realized shock duration. And what I have on the vertical axis is the additional ELB duration and the size of output gap overshooting, okay? And as you can see, additional ELB duration and the size of output gap overshooting depends on the realized shock duration, okay? And now let's think about the history dependence of optimal sustainable policy, okay? And as you can see, when the crisis shock lasts only for 1 quarter, the realized outcome for policy rate output gap, they are not that different among these policies. But as the shock duration gets longer, you're gonna start seeing the difference, okay? And when the punishment duration is shorter and the optimal sustainable policy is closer to optimal discretionary policy, you see that as the shock duration increases, you don't necessarily increase the additional shock duration, additional ELB duration, or you don't necessarily increase the size of output gap overheating, okay? So here I see the history dependence for optimal sustainable policies, and as the punishment duration gets smaller, the optimal sustainable policy gets less and less history dependent, okay? All right. So especially, if you look at this n equal 20 case, basically there's no history dependence. You're gonna promise additional ELB duration, but there's no history dependence. All right. And this case looks very similar to what Carl Walsh in his 2018 paper called Simple Forward Guidance Policy. Under his forward guidance policy, the policy rate is kept for a fixed duration, regardless of the shock duration, okay? And I'm just gonna say that one key criticism against the open commitment policy is that it's too complex and difficult for the public to understand. But what I show is that the optimal sustainable policy is less complex in a way, and thus overcome this criticism. Okay. So I have a result that is based on a forward-looking Phillips curve. So all the result I was showing to you was based on a static Phillips curve, but qualitatively everything goes through with forward-looking Phillips curve. And also, So in the latest version of the paper I'm working on, I'm comparing this optimal sustainable policy with average inflation targeting policies. So optimal sustainable policy is, in a way, just you can think of it as a device to capture something in between discretion, perfect discretion and perfect commitment. And there's a literature on imperfect credibility by Martin Bodenstein and so on. That's another way to capture something in between discretion and commitment. And average inflation targeting is also one way to, if you change the, the duration, the time window over which you average inflation rates, you can, average inflation rate in which the averaging time window is infinity is the same as price level targeting, which is very close to commitment policy. So average inflation targeting is, another way to capture something, continuum of outcome between discretion and commitment. And in the latest version of the paper, which we are still working on, we compare optimal sustainable policy with different ends with average inflation targeting with different time window. Okay. So let me wrap up for now. So what I show in this paper is that even when the optimal commitment policy is not credible, the central bank can still credibly promise to temporarily overheat the economy. You have a shorter ELB duration and smaller overshooting of inflation and output gap under the optimal sustainable policy than under the optimal commitment policy. But you can still do much better than the optimal discretionary policy. In particular, welfare cost of the ELB is substantially smaller under OSP than under the optimal discretionary policy. And also, optimal sustainable policy is less history dependent than optimal commitment policy, which may make this policy a little bit easier for the central bank to communicate to the public. Okay. Any questions or comments?
Can I ask a question?
Mm-hmm.
So I have a comment and then I have a question.
Mm-hmm.
So the big comment is, can I think of your paper that is a nice framework in which you can decide on how much to punish the central bank, and based on that, you give the ability to the central bank to smooth consumption over time, and so maximize welfare, to smooth fluctuations, because so that is telling me the less is costly to deviate, the much the central bank can smooth fluctuations and can optimize welfare. And your framework is flexible because you can command the degree in which that happens. So that is my first things. I think, is it the big takeaway that you think, is it, am I making justice to it? And then I have, based on this, I have a comment on the key part that is this punishment. So this punishment, I think, is critical, how you do it. And you gave us a good hint looking at the chairman tenureship in the central banks. But I think that's fine, but it is also based on many other considerations, how long you stay on the tenure as the chairman. One other thing that you could think of is maybe you can infer how damaging it is to deviate from your mandate, from the actions of the central banks. You can use the model and say, I don't know, what this punishment is, but I look from the facts. Do central banks deviate a lot from the target? And that can give you a sense to what extent it is costly to do so. If it is very costly, central banks will be very wary on deviating. If it's not, they will do it most of the time. And maybe that could give an additional feeling on how punishment is. And this model would help us to read the reality and saying, look, if there is this deviation, it means that this channel is important, or is important in certain times. Something like that, I felt that could be interesting to explore within your framework.
Yeah, thanks.
Thank you.
Thank you for your comments and questions. So in a way, so if the private sector agents, punish the central bank in a most severe way, yeah, that's going to give you the discipline to the central bank, and that helps the central bank to smooth output gap and inflation over time. And so, yeah, but it's a little bit tricky because literally in this model, central bank and private sector agents have incentive to collude. So that's why we need to think about like a renegotiation proof. So here, the central bank is maximizing household utility. So in a way, you can say, okay, central bank, promised this, and private sector believes this. And once the shock disappears, central bank could renege, but the private sector have incentive to forgive that because, this zero output gap maximizes the private sector's welfare. So that's, yeah, I don't know how to think about it. But anyway, for your question, so how damaging it is to, so I don't know, like, so this overheating policy hasn't been really tested. I mean, ECB and the Fed just moved in this direction. And in the US, there is overshooting of inflation. I don't know how long it lasts, but there's many other things that's different from time inconsistency that's going on. So yeah, I haven't thought.
I felt that maybe one thing is that, okay, let's see from the actions of the central bank, there are a myriad of things that can happen. But if you see that there are some significant deviations, or if there aren't, that is informative on how costly it is to deviate. Because if the deviation, I would expect that you will find some degrees of deviations, and then you could use that to interpret what is the severity of the punishment.
Right.
Something along these lines, where you look at the data and then you use the model to infer what's the cost. It's something tenuous that I had in mind. It's nothing.
Yeah. So here, like, when we think about these things in terms of data, we need to think about, promise and deviation from promise, even before like a ELB period, going back to more, older data, because, this, it's very recent that the central banks are thinking about this kind of policy. And also, in reality, the central banks do a really good job to make the promise as vague and as ambiguous as possible. And so, yeah, that's gonna make the straightforward kind of mapping of this this theory to real world a little bit challenging, I think.
Yeah, I have a question on that also, like on the policy implication, or what can we learn from this for practice? So do you think that it would be possible at all with your model or an extension to give some quantitative advice, or is it just too hard to basically to estimate what would be the real world frequency of crisis and the commitment? And should we rather say, okay, what we learned from your paper is you can still do this kind of policy but lower for longer, but do it not too hard, and then you're more likely to have something that is will not be punished, basically? How do you see that?
Thank you for your question. So I see my paper as more like theoretical, giving one reason why you don't need why time inconsistency problem can be overcome. And I'm at least at this stage, it doesn't have too much like empirical content, to make some kind of estimation plausible. But if you think this framework as a one way to capture something in between discretion and commitment, there are many other frameworks like imperfect credibility or commitment literature. And that approach is more tractable because you can use linear to solve the model. So there you can do some estimation. But here, here it's a nonlinear model. And yeah, it's going to be challenging to estimate this kind of model. Yeah.
Sorry, Taisuke, I had also a question. How would your model and your paper work in a world where governors have finite terms of 4 years or 8 years? So one governor may not likely see another crisis coming. Mm-hmm. So he has strong incentives to not care about the future crisis that is going to come in 15 or 20 years, right?
Yeah, so, yeah, I mean, even if your tenure duration is like, let's say 5 years, then, well, you make promise and then you leave before people are thinking about whether to fulfill the promise or not. So, so one way to kind of like one lesson you could draw could be that it's going to be good to make reputation institution specific as opposed to like individual specific. If people think the Fed is a kind of like a continuous entity that doesn't change drastically when the chairperson changes. And I think the Fed has been doing that. There has been a continuity in the regime, as opposed to the Bank of Japan, in which when Kuroda came in, there was a kind of regime change. And when Kuroda leaves, that's going to be probably like another regime change. So I think it kind of tells you, making reputation institution specific. Or you could say that making the tenure duration of chairpersons longer. So if you look at the Supreme Court in the US, the appointment as a Supreme Court judge is a lifetime, tenure. So there are people with 20, 30 years of, being in the position of Supreme Court judge. So maybe that's,
It's okay.
A central bank could do something like that as well. I'm not sure if it's a good idea or not.
Taisuke, here I want to throw this because I think could be important for you. So when you have this reasonable value for N, another thing that you could look at, in some central banks, when you deviate from your mandate, you need to report back to the parliament. That happens in the UK. So maybe a good way to provide evidence on whether it is damaging or not is to look at those instances. And I remember in the Bank of England, there were such instances where there were some deviations and punishment because they had to go publicly and declare what happened and what are the countermeasures that they have in place to counteract this. And I think that the Bank of England does it. I'm not sure about the Fed, maybe the Bank of Japan. They have a similar accountability framework with the parliament, but I think that will be a more direct way than just saying tenure, a duration of the tenure, because that's based on political consideration, an array of stuff that we don't really know.
Thanks. Yeah, I think that's insightful comments. And so I think like the Fed is trying to do the strategic review every 5 years. So the kind of like the timing of the strategic review can be also, connected to this, in addition to what you said, which is reporting to the, government.
All right, well, thanks very much, Tai, and everybody for the comments. I'll throw something out and perhaps we can discuss in the break, and that is that could we think of QE as a way for the central bank to tie its hands, right, as they've argued? So in a way, can it choose its own N and can it implement it with QE?